parallelogram. So just like a parallelogram, opposite sides are parallel. Because rectangles are parallelograms. Okay, they have opposite sides that are parallel. They have opposite sides that are congruent. They have opposite angles that are congruent. Consecutive angles are still supplementary. And the diagonals still bisect each other. I almost call them diagonals. Just put bisect and diagonal together, diagonals. So those are all the properties of parallelograms that are still true for rectangles, because rectangles are a type of parallelogram. But we get a little bit more specific. It has all right angles. You already know that. You know that in a rectangle, all the angles are right angles. So they are 90 degrees, just to be clear. Those are 90 degrees. And the diagonals are, how do those diagonals look different compared to the diagonals of the parallelogram? Look at the picture here. Okay, on the parallelogram, the diagonals were not the same. What about these diagonals? They are the same. Okay, so a rectangle is a parallelogram that has congruent diagonals. Okay, it is a parallelogram that has congruent diagonals. All right, so let's use these properties here. All right, so we've got a rectangle there, KL, side KL. Well, opposite sides are still congruent, so it's 25 meters. NL is a part of that diagonal. It is half of that diagonal. Diagonals are still bisected, so it is the same length as JN, so it is 13 meters. KM. KM is the entire other diagonal. Nothing is labeled on KM, but what is true about our diagonals in a rectangle? They're congruent. So KM is congruent to JL. How long is JL? 26. So KM is also 26. Questions about anything I did on those three? Okay. Angles. Angle KLM. What's the measure? 90. All of our corners are 90 degrees. That's 90. Okay. LMK. LMK, let me get another color here. LMK is that, it's 68, okay? Because that piece at K is 68, then the opposite, see how it's on opposite sides of the diagonal? It is also 68 degrees. LJM. LJM. All right. So let's see here. I got 68 right here, and I got 90. 90 minus 68. Yep, 90 minus 68 will do it. So 22. Yep, 22 degrees for LJM. There are several different ways that I could go about explaining why that is the way that it is, but it all has to do with the way that those diagonals are intersecting with each other in the parallel lines. Okay, so let's look at example number 4. If PQRS is a rectangle, find the measure of angle QPT. So Q to P to T, we are wanting that piece right there. That piece right there is not labeled with anything. So So let's go to what is labeled. We've got this angle and this angle. They are opposite from each other, so they are equal to each other. So let's solve for x. Subtract 10 from both sides. 6x minus 17 equals 1. Add 17. 6x equals 18. Divide by 6. X equals 3. We didn't want x. We need that angle QPT. So we got to plug x back in. 16 times 3 minus 17. You say 31. Okay, and that's 31. Is that still our answer though? No, we're wanting the other part of that right angle. So we got to subtract that from 90. 59. 59, not 49. 59 degrees is the actual answer that we're looking for.